Problem 29. A student takes a true-false test that has 10 questions and guesses randomly at each answer. Let x be the number of questions answered correctly. So we know this problem is a binomial problem because the number of trial is fixed. And for each trial, we have, that means the number of the question is 10 questions, is 10 trial. So for every trial, that means for every question, there's two outcomes, correct or not correct. The outcomes are independent. The trial are independent. So for example, you know the answer for the first one, it doesn't mean that you also know the answer for the second one. So we identify the n is 10. The p is the probability of success. In this case, we are looking for the correct answer. For every trial, the probability for getting correct answer is 0.5, so p is 0.5. We can use the formula to plug in to find out the answer, but I'm using the GeoGebra in this case, the technology. So we will go to GeoGebra. You go to internet and you type GeoGebra. You see the word GeoGebra Classic in here. GeoGebra Classic. We will click on GeoGebra Classic. And then we will click on probability. We will choose binomial. And then the n, we will tap 10. And the p is 0.5. I took a picture of this screen and I transfer this picture in here. Now question A, we want to find the probability of getting 4, that means 4 correct answer. So right here you can see that now the answer is 0.2051. Problem B, find the probability of fewer than 3. Fewer than 3, that means probability of 2 or 1 or 0. They are less than 3. Using addition rule, we will have probability of 2 plus probability of 1 plus probability of 0. So they are here, here, and here. What do is you will add them up. However, you just go ahead and click, and it will highlight like this for you. And you look in the answer right here. So you will get the answer, and that is 0.0547. So I go back to the GeoGebra and I just go ahead and click on the probability of 0, 1, and 2, and I get the result in the box that you can see 0.0547. That will be the adding result for you. And in problem C, to pass the test, the student must answer 7 or more. So we want to calculate the probability of the student get 7 answer correctly or more than 7. So that would be 7, 8, or 9, or 10. So we want to find the probability of 7 correct, or 8 correct, or 9 correct, or 10 correct. Similarly, like problem B, this is the additional rule. We will add them up. Now I will click on the 7, the 8, the 9, and the 10 and read the answer. It's give me 0.1719. 0.1719. 0.1719. And the question asking us that would it be unusual for the student to pass and explain? You recall the word usual. So 0.05 or 5% is the cutoff point. If we have the probability that's greater than 0.05 or equal 0.05, it can be usual. It will be usual. And anything that less than 0.05 is could be unusual. So 0.17 is about 17%. So 17% is more than 5%. So 17% is under usual range. The question asking us that it will be unusual for the student to pass. So we say no, that will be usual for the student to pass.